Warm-up number 1. The solution for the warm-up should be to find a common denominator of 10 for 5 and 2. The lowest number that 2 and 5 will go into is 10. If I multiply this 2 by 5 to get 10, I multiply 1 by 5 to get 5. If I multiply 5 by 2 to get 10, I multiply 3 by 2 to get 6. 5 plus 6 is 11 over 10. Warm-up number 2. The solution for this is a common denominator over 15 for each fraction. 3 and 5, the lowest number they both go into is 15. 3 times 5 would get me 15, so 5 times 2 is 10. And 5 times 3 would get me 15, so 2 times 3 is 6. 10 minus 6 is 4. Put that over 15. Last warm-up problem. The lowest common denominator between 6 and 10 will be 30, not 60. 5 times 6 would give me 30, so 5 times 5 is 25. And 10 times 3 is 30, so 1 times 3 is 3. 28 over 30 is not the final answer. You can reduce that. Cut both of them in half to get 14 over 15. Pick a number from 1 to 20 for the lottery. The winning numbers today are 15 and 19. Next up is the homework check. That would be the after-test assignment from Friday. The objective for today is the Pythagorean Theorem, a squared plus b squared equals c squared. That was one of the most missed problems on the benchmark test. This was one of the most missed problems on the benchmark test, where you're given a triangle such as this. It's a right triangle, and let's say you know this and this, but you're searching for the missing side. So we're going to do that today. Example number 1. If I did have a triangle that was right and I had sides that were 3 and 4, but I did not know this one, I could solve it using the Pythagorean Theorem. First, before we do that, you must know that this is called the hypotenuse. And this is a leg, and this is a leg. In terms of the formula, this is A, B, and C. A and B are interchangeable. You can assign either number the value of A or B. Usually it's the smaller one that's A, the larger one that's B, and then the hypotenuse is C. But it's not going to hurt anything if you interchange A and B. Use the formula. A squared plus B squared equals C squared. A squared plus B squared equals C squared. Plug in the numbers. 3 squared plus 4 squared equals C squared. And then simplify 3 squared and 4 squared to get 9 plus 16. 9 plus 16 is 25. To find the value of C, you need the square root of both sides. The square root of C squared, just as the square root of R squared from the cylinder problems was R, the square root of C squared is C. And that's what we're looking for. The square root of 25 is 5. Therefore, the hypotenuse is 5. This triangle is shaped a little differently or in a different position, but you still do the same thing. 6, 8, and we don't know what the hypotenuse is. The formula is A squared plus B squared equals C squared. 6 squared plus 8 squared is C squared. Simplify the 6 squared and the 8 squared to get 36 plus 48. Add those together. Or not 48, that should be 64. My fault. 36 plus 64. Add those together, and that will be 100. And then find the square root of both sides. Answer should be 10 for C. Drop this one off at the table up here. In this right triangle, we know we have 15 and 20, but we don't know this one. Find the value of C. Drop it off up here. The solution for the practice problem is to do 15 squared plus 20 squared and set that equal to C squared. Simplify that to get 225 plus 400, which is 625. And then find the square root of both sides. Your answer should be 25. A bonus problem, 1/3 plus 2/7. The solution for the bonus problem should be 13 over 21. Bonus problem number 2, 5 over 6 minus 1 over 8. Answer to the bonus should be 17 over 24. Another example problem. This is a right triangle, and in this case we know the hypotenuse to be 25 and one of the legs to be 24, but we don't know this one, so I'm going to call it A. Now remember, your formula is A squared plus B squared equals C squared. You can still plug in everything you know. We don't know A, but we do know B to be 24. And we know C to be 25. The problem here is that you have A squared on the left, and it's with that 24 squared. So in order to get it by itself, we must first simplify everything that we can. 24 squared is 576. And 25 squared is 625. We want the A squared by itself, so we solve it as an equation. Keep the A squared on the left, but move this plus 576 to the right side and make it minus 576. 625 minus 576 is 49, and from there you would find the square root of both sides. The final answer would be A equals 7. And as a review, this is what's missing, the A. That's why we put nothing in there, or there. But we simplify everything else that we plugged in. And whatever is with that A squared, in this case 576, move it to the right side and do the opposite, minus 576. Simplify that to 49 and then find the square root of both sides to get 7. In general, you could write a new formula that looks like this. A squared equals C squared minus B squared. And that comes from the same formula up here. We've simply solved it for a different variable. So when you're missing a leg, you can remember this formula and do that right off the bat instead of writing this, this, and this. It would take you straight to this part there. Practice problem. We have a right triangle, and in this right triangle we know the hypotenuse to be 26 and one of the legs to be 24. We're missing this one over here, and we'll call that A. Find the value of A. Solution for the practice problem. Remember the shortcut formula. It is A squared equals C squared minus B squared. A squared we don't know, but we do know C squared to be 26 squared, and B squared is 24 squared. So A squared equals 26 squared, and what is 26 squared? 676, yes, and 24 squared is 576. So when you do this, you end up with 100, and that's equal to A squared. So you need the square root of A squared and the square root of 100, and back up here that would give you A equals 10. Another bonus problem. 3 over 4 minus 1 over 8. Alright, for this we need a common denominator of 8 for the bonus. That means this one does not change, but you have to multiply 4 by 2 to get 8. And 3 times 2 is going to be 6. So 6 minus 1 is 5. 5 over 8 is the answer for the bonus. Another practice problem. Here's a right triangle. And in this right triangle, we know the hypotenuse to be 30, and we know one of the legs to be 24. We don't know this one, we'll call it A. Find the value of A. The solution for the practice problem, we're missing A, so we need to do A squared equals C squared minus B squared. And C squared is 30 squared, B squared is 24 squared. Simplify those two to get 900 minus 576. 900 minus 576 should be 324. And then you'll do the square root of both sides to get an answer of 18. Another bonus problem, 9 over 10 minus 3 over 5. Solution for the bonus. The common denominator is 20. And you have to multiply this one by 2. And then this one by 2 is 18. This by 4, so this by 4 is 12. That's 6 over 20, which will reduce to 3 over 10. The last example is one that we really don't even need to go through, but we'll put it up here anyway. And that is if you're missing something that is called B. And we have A and C. If you're missing B, it's very similar to the last type of problem. It would be B squared equals C squared minus A squared. Or you could skip this formula altogether if you call everything that's a leg that is missing A. So no matter what side of the triangle it's on, if you call it A, then you end up using A squared equals C squared minus B squared from the last example. So there may not even be a need to use this. There's nothing wrong with calling everything that's a leg that's missing A, unless you're missing both of them, and we're not even doing those types of problems. That's not on the graduation test. You don't have to draw the triangle. You have to write the formula out, plug in the numbers, show all the steps, simplification, and so forth.